So yeah, if anyone saw the end of the previous stream, I was chasing down a bug with the model loading. And annoyingly, I figured out the bug immediately after the stream ended. So the issue is that this model had like weird broken geometry, and I couldn't figure out what it was. I was like going through all the code trying to figure out what it was. But it turns out it was just a hash collision issue, because I wasn't using basically a large enough hash key for the number of vertices in the model, and it was colliding. So it was like thinking that one of the faces was one of the other faces. So that was fun. But I figured that out, and that's nice. So it's all working nice now. And I did a bit of work today as well, like an hour or so ago. But I just need to continue doing some work with the build tool. So I'm gonna keep doing that, and then yeah, we'll see what happens. Also have some debug stuff drawing. Hey, how's it going? Welcome back. Welcome back. Not sure if you just heard my monologue, but I fixed the bug from yesterday. So that's nice. But yeah, just keeping on working. Keeping on. Nice. Yeah, today's probably gonna be a shorter stream as well. Not a 8-hour grinder like yesterday. I don't have too much time tonight, so I'm just gonna get some nice housekeeping stuff done. Make some cheat codes. Yeah, I really should. I need to add no clip mode, because right now I'm stuck now as like the player controller. But I have this in-game, well, I guess in-engine console thing, so I can like write commands. So I could add one for no clip, which would be kind of cool. Actually, no, I'll do that right now. That could be interesting. So what do we have? We have the movement controller, which is here. And then let's see. Movement update. So this is basically what we want to do. So like, if no clip. I guess if not no clip, we'll do the player movement. We'll do this. So we can do if no clip, else. So I guess if we're not no clipping, what we want is for these to move us around with the camera. I'll just do this for now. And we'll have to define this at the top. And include that, so it should hook it up to the console. And then what do we want the movement to be? It should all be in there actually. Alright, so no clip will just move the camera's position along the forward vector. Call this forward speed times delta make this pretty fast. And then backwards, we'll just do the other thing. Hey, how's it going? Welcome, welcome. Alright, I'm adding no clip right now because someone requested it. So now if I go no clip, I should have, oh, I'm backwards. Alright, let me, oh, this should be S. So no clip. It's actually really convenient because then I can go through some of the levels that were broken. Let me add strafing to the no clip as well. So we have a forward vector. We need like a sideways vector then as well. Sideways, or like a strafe. I'll call it sideways. Equals. It's basically our right vector multiplied by the camera's view rotation matrix. And since this is, let's see, it's going to have to be a vec4 because this is a rotation. Actually, it shouldn't matter. Be constant, and that can be just for symmetry's sake. Oh, I have my I have it backwards again. Dang it. Interesting. I guess, yeah, A would be negative in that context because it's to the left. Now let's add keys to go up and down as well. I'm going to call these speed forward. Just group these together. I'm just using the mouse look. Whoa. Oh, that's right, I'm not using delta time. And then the keyboard to move is how I have this set up. And then we can add some extra modifiers. Modifier equals just 1. We'll have shift speed us up. And then we'll have control speed us or slow us down. I think that should look fine. Alright, yeah, it looks good. I'm happy with that. And then we can actually register this as a proper command, because we're not quite doing that yet. Or we're not doing that. So I have this... I forget what it's called. Console. What's the type of this called? My programming brain rot. Here, let's just copy this. This is basically what I want to do. No clip. Enable camera no clip mode. And then no clip is camera.getBool. No clip. No, not today. I'm probably only gonna go for like an hour, hour and a half. Today's a short day. I don't have all day. Where did I learn game engine architecture? How do you reset the... How are you saying the buttons at the bottom of VS Code? Okay, let me answer one at a time. Game engine architecture, I kind of just learned organically, I guess, through projects over time. So I've been like doing game development stuff for like, well, technically 18 years, but mostly like, realistically, like more like 14, 15 years. And I've been doing game programming, like game engine programming for the last 7 or 8 years. So I've just kind of learned over time through trial and error, really. All right, yeah, no clip. So now we actually have an actual command here, which is cool. And I can just go, just toggle it by calling it. And then binding it to a key would be nice as well. Okay, I have figured it out. I just haven't fixed it yet. I just need to subtract 1, basically. It's not a big deal. I think it actually might be like a Blender export thing. Yeah, keep bind end to no clip. I can do that. Yeah, sure, that could work. So basically I just do... Well, first we'll check if the console isn't open. Actually, I shouldn't have to the way I set this up. Ever learned everything at home? It actually happens to everything, the textures. Because like you can see this license plate is also flipped. It should be like, the F should be on the other direction too. It's just everything else looks like fine. So it's flipped along the... Interestingly, it's like flipped along the X axis rather than the Y axis, which is weird. So I learned everything at home. It's it's just a complicated story because there's like, I learned things in just a lot of places. So like most of my game development knowledge is self-taught just through like doing projects. I had a computer science, I did a computer science degree at university, But I didn't really learn anything game development related from that. It was more like computer science fundamentals, right? The theory. Oh yeah, don't worry. I'll get to your message. I'm still thinking about that. And then yeah, and I also worked at a game studio for a few years, so I learned some stuff there. So it's just like an accumulation of knowledge from various places. Oh, interesting. When I press N, I snap back to where I used to be. I need to change that. That's fine. Here, 1 second. Let me fix this, and then I'll get to your question. And then I'll get to some other work too. Player.position equals camera dot. Here we go. This should fix this. So if I no clip and then on no clip, nice. I guess I can reset gravity as well. It's a top-down projection. Okay, yeah. How do I get the buttons on the bottom of VS Code? So that's actually one thing I'm going to work on today, or something similar to this. So this is a custom plugin that I wrote for my build system. So like unfortunately you can't download this. Well, you can because the source is in the GitHub link, but it only works for my game engine. And it's basically just like some custom widgets that when I click them, they do stuff. And it's just like a VS Code plugin that I wrote. And if you've never written a VS Code plugin before, I can kind of show you what that looks like, because it's kind of interesting. So basically, VS Code plugins are just JavaScript. So you can see I'm like creating all my widgets here. So like here's the build widget, which is like this one. And then I bind them to a function. There should be a function in here somewhere. Here they are. Well, it actually calls this command, and then VS Code will associate that with one of my other JavaScript functions. So I just have like a custom thing. Is the map just texture? Yeah, it's just a top-down orthographic projection. And no, I didn't take anything game-related in university. Well, there was technically a graphics course I took, but it wasn't game-specific. It was just like... It was actually really kind of weird. It was like graphics fundamental type stuff. But it was very introductory, so it wasn't very insightful. It kind of covered stuff I already knew. Because I programmed before I went to college. So I already came in with like a decent amount of just knowledge about how to do things. Obviously, I still learned a lot, but yeah. Anyway, so yeah, basically what this a nuclear reactor, and he makes it work. Okay, so anyway, this thing at the bottom. I know he left chat, but I'm gonna work on this, so I'm gonna explain it briefly. And I was doing this yesterday, so if anyone was here yesterday, you'll know what I'm doing. So basically, all this does is it drives basically a command to a shell script or a batch script I just call it boot for like bootstrap. So I can do my whole engine's build and compilation. I can drive through a single batch script that I just pass in like arguments to. So like I can compile the game from just the terminal by passing in the project name. And it does all the build stuff. It's like processing all the assets. And then here we go, we're in the game now. And like the cool thing is I can change, I can change which graphics backend it's using. So I can make it use OpenGL if I want to. And it'll recompile to OpenGL. And like I can change which compiler it uses. So I can use like Clang if I want to. So now it's using Clang. I don't know why it's stuck on the assets. Interesting. I think I just crashed it. What just happened? Oh no, here it goes. It just hung for a long time. That was weird. I wonder why it hung for so long. Interesting. But yeah, the point is I can drive it through the batch script. And the reason I do this is because my game has, the engine has like a two-step build pipeline. So the first step is it has to run this build executable, this build.exe. And this build executable is also compiled from the shell script. So the shell script just launches everything. So it compiles the build executable. And the build executable is basically responsible for packaging all my assets, dealing with shader compilation, object, the entity system, and it does some code generation as well. Yeah, pretty much. It's pretty much you just like add everything through VS Code. There's no editor other than VS Code. But yeah, so yesterday I was working on adding material, proper support for materials and model loading. So now I have, if I run the game, which I kind of demonstrate, I have models loading, and I have little debug lines drawing as well, which is kind of cool. Just as a little test I forgot to turn off. But like here's a model. These three are one model split up with 3 meshes. This is like obviously one model, but it's made up of a bunch of meshes, and each mesh has a different material. And like the boat is just a single model, so you kind of get like a bit of everything here. But the cool thing is the build tool handles basically packing all of these raw model files, all these raw asset files, into basically a more optimized binary file, like binary asset file that my game engine runtime loads on startup. So if I show off what that looks like, if I navigate to this project's output directory, runtime, set to extra large icons. So this is like the output directory of like the debug build. So there's a lot of extra stuff in here. But the main thing we care about is the game's executable, obviously, and then there's this binary file, which might be hard to see on stream because of the low resolution. But this is like a single file, and then these two get shipped together, basically. So this is like all the asset data, and then this is your runtime executable. And my build tool is responsible for basically compressing everything into this single binary file. And the cool thing is it handles caching of assets. So like if I just kick off a new build, see it like it's really fast because it doesn't have to do anything because nothing changed between builds. But if I go in and say, let's close this, and I go to Blender, so here's like those cube models. If I like update this mesh to just like make it look like something else, and then I re-export this. So this is an object file I'm exporting it as, a model format. So there we go, we just exported it, so we updated it. If I go to rebuild now, you can see that it's still fast, so we're in the game now. But if we look at it, you know, now we have the new arrangement. So if we go back to this, we can see that like the shaders in the object system code, all that data didn't get touched, so it didn't have to do anything. But one of the assets got touched, so it basically rebuilt only the thing that changed. And I can demonstrate with even more. So if I go in and change one of these textures, so like if we open up, here's like the blue texture. If we open this thing up in Paint, open with Paint, and we just make this guy, I don't know, let's draw some like yellow on him, and then we resave, and then I can rebuild this, and I have another flag that makes it more verbose. Verbose equals 1, and I rebuild. We can see what it's doing, but first we should see that now we have yellow on our texture. So it rebuilt just the texture, and we can see that definitively by looking at the output of the build. So we can see basically from the start, it like looked through all the assets, it checked the cache, so it compared them to the previous build. It saw that one of the assets changed, part of the asset binary like block changed, and now it's going to go through each asset and check more thoroughly what has changed. And these lines in like purple here are basically saying that this asset didn't change, so it's pulling it from the last build, so it doesn't have to do anything really. But if we get down to the texture that changed, this is the only one that actually got rebuilt. And when I say built in this context, I mean I'm like generating bitmaps. I'm packing it into an... Well, I guess this texture isn't getting packed into an atlas. But I could be packing this into an atlas. And then, yeah, all of these end up in the binary file at the very end. So, yeah, it's like a interesting build system. Did I ever get burnout? Yeah, I get burned out every so often. If you look at my GitHub profile, I think I have the activity thing as like public. The little activity graph thing on GitHub. You'll see that like over the summer, I basically didn't program much at all. I took like 4 months off. And I kind of had burnout during that time. Also, the weather's nice in the summer and I don't really want to be sitting inside every evening. So it seems like most summers I kind of go through a phase of burnout. But it's currently winter and I'm feeling motivated, so I've just been grinding in my spare time. So yeah, so that's the asset system in a nutshell. And it's cool because it works with all the asset types. So like I can go in here and, you know, change a shader, for instance. And like I can add, let's just pick this one, just make it do something else. And then if we recompile after we close the window. So we'll see this time. Now I'm getting red because I made the shader change everything to be red. And if we look at the output, yeah, it basically, I guess in the shaders have to compile everything because they can be dependent on each other. So that's one downside, is all my shaders are kind of like ultimately one huge system that kind of relies on each other to compile. But yeah, it only compiled shaders here. So you see it like restored the object system from cache. Took basically no time. The assets didn't take much time. So yeah, I basically have everything working actually. I'm pretty happy with this. But I am missing some logging from this file. So like if I go back and I change the model, just update this and I re-export. Hey, how's it going? Welcome, welcome. And I changed the shader back to not being red. And if I rebuild this, so this is my verbose output. So hopefully that model looks like it does. I think that looks right. It's up there. See, when I change the texture, I have like all these texture things being printed here. But for all of these other asset types, I don't print anything, and I want to print stuff. So I basically have to do whatever I'm doing for this in the... specifically, I want it in the models, because the models are actually kind of heavyweight asset types. But maybe the materials as well. I might want the materials. I'm going to do the models for sure, though, because these are like heavy assets, and I want to be able to see, you know, which ones actually got touched from cache or not. So yeah, let's just write that. Let's add that to the build output. So we just have to steal this. Well, I don't even know where I write this. I would assume in the textures. Oh yeah, here we go. Log asset cache. Oh, I didn't realize I wrote convenience function. Helper functions is what I'm looking for. I didn't write helper functions for these, which is, or I wrote helper functions for these, which is super convenient. So we just need to add these to the models. What am I doing? Yeah, so it's basically saying that we either cached it or we loaded it. And then model.name.cstring. And we can play around with this and see if this is working correctly. I didn't think that was going to be so easy. I forgot I wrote that helper code. Yeah, so we just rebuilt everything because we changed compilers. So if I go in here and I change the model again, and just recompile, we should see pretty much everything be restored from cache except the cubes model, which is the one we just built. And that's what we see, which is sweet. And let's revert the texture as well. I guess it doesn't matter, but we can just demonstrate that that works. This Skyrim is very strange. All right, and let's look at the log. Let me think if there's any other assets I want to, yeah, so this texture got touched, so it changed. Sprites, these are all like rely on each other as textures, data assets. I guess skins are also potentially cached. Maybe not though. It's really models that we care about. Oops. Oh, your name is also Jared. Sorry, I didn't see that that comment. Nice. Do I have a favorite feature of my engine or in general? My favorite feature of my engine is my shader language. I wrote my own shader language. And I'm proud of it because it's actually pretty sweet. All right, yeah, so the shader language is interesting. I've talked about this on previous streams, but essentially my engine supports multiple graphics backends. So basically, in other words, you have like OpenGL is one of the APIs, DirectX is another one, Vulkan. On Mac, there's one called Metal. And each of these graphics APIs are just like ways of communicating with the graphics card ultimately. But annoyingly, each API basically takes its own shader language. This is a problem that you encounter if you have an engine that supports multiple graphics APIs, because you need a way of kind of bridging the gap between the shader languages. So like the easy solution is you just don't bridge that gap, and you just force the user to write like multiple copies of a shader in each language. But I decided that was really annoying. So I wrote my own sort of universal shader language, I guess you could say. So this is what it is. So like some of the syntax is just kind of like my own language syntax. But at build time, you can see there's whole stuff dedicated to shaders in here. So my build tool actually parses and I guess compiles these into the target shader language depending on the graphics API that you're running. So if I go into like the output again, part of my output is generated code. So like I have a generated code section, and in here are shaders. So like here's the kind of my own shader language. So this is the shaders code you actually write for like the engine for the game. And then here's generated DirectX shader code, HLSL. So basically it took my shader and it translates it into this. And then this runs just natively on DirectX. But if I switch to OpenGL and I just recompile, we'll see that this has changed to, it used to be HLSL, but now it's GLSL, which is OpenGL's shader language. And here's the code for that. So essentially my compiler does like, it basically, it parses the shader code, generates the syntax tree from it, which is like a very common compiler method. It's like how you compile languages. So I generate a syntax tree, and then from that syntax tree, I actually just generate code in this instance. My output is code. But from the syntax tree, I just like, if I'm running OpenGL, I generate GLSL code. If I'm generating like HLSL, I'll do HLSL code. And I also have Metal working for Mac as well. So because I don't just translate shader code, so that's a great question, actually. So I'm not just translating shader code, I'm actually doing additional stuff as well. So if we go back to my shader language, we can see up top here, like these vertex format things. Like here's my vertex format for the forward shader here. And like my vertex shader takes that in as an input, right? That's like my stage in. My build tool also parses these and generates me a bunch of boilerplate code for my engine. And the same with like uniform buffers and constant buffers and all of that. So like I can demonstrate that most easily by just adding in a new parameter here to like my uniform buffer. So I can just call this like color. So here's like a uniform buffer that I just have for this shader. And I can just access this color here. I'll just multiply it by the output just so we can see it do something. And then if I just go into the main function, wherever I'm rendering this, I guess here is where it's using it. See, I have this uniform buffer thing in my C++ code. So like I can go in here and just do like .color now is equal to, I don't know, let's say like blue. And if I rebuild this, it's just going to automatically work, right? It just works now. Or like I could go a step further and have like a static color up here, color, and then hook this up to a console variable, and then use this and recompile. And now I have this hooked up in my in-game engine here. And the way that this works is that this uniform buffer thing is actually generated header file code, basically. So my shader compiler generates me some C++ structs that have the correct padding alignment for each shader language. It also does a bunch of boilerplate for the vertex formats, the instance buffer formats, all of the alignment and binding stuff you would need. No, it's all written myself. Hence the no library thing in the in the title. So yeah, it's that's my favorite feature of the engine, I guess, because this makes the writing actual graphics code just so easy and fast. Because like I can just rapidly iterate, and it works cross-platform. So yeah, I can show what the actual code looks like for the compiler, because it's all in the GitHub too if you want to take a look. But like it's in the build system here. Build shaders. So I have this like build shaders thing, this folder. This has like all of my compiler and translation code. So like there's multiple passes. Like the first pass, actually there's a preprocessor that runs, so I support preprocessing. And this does a bunch of stuff. And then the parser basically converts it to a syntax tree. I have an optimizer, which just like does dead code removal, which is kind of not necessary because the each language will also do this. But then like you can see each of these is for like each output. So I have a GLSL output module here. I have an HLSL one and a metal one. I have a Vulkan one in here, but it's not actually doing anything yet. So yeah, that's how that works. In a nutshell, let me go and remove this debug code though from the project before I forget. Because I don't actually need this. Yeah, the syntax highlighting is another good question. So, no, the answer is no, I did not write my own. It's called a language server is the word you're looking for, I think. So yeah, you're asking how I have syntax highlighting in my shaders. This is something I was careful about when I was designing my language. So basically my language is fully compatible with C++ syntax. So all of this syntax is actually just because it's running a C++ language server for IntelliSense, for like syntax. So all of this just works because I've made sure that the grammar of my language also just works as if it's C++. So it just sees things correctly. Well, I guess you kind of asked both questions. You both asked a similar question. Thankfully, the shader languages all basically do the same thing, because ultimately the shader language is running on the same hardware, right? Like if you're running HLSL or GLSL, ultimately your graphics card has a set of operations, you know, a set of what's the word I'm looking for? Like assembly operations, right? That it can like is hardwired to run. So like thankfully the shader languages all map to like the same general concepts. So translating them isn't actually that difficult from like a theoretical perspective of like making sure each language does the same thing. It's more just like the grammatical differences of the languages make it a bit tricky. Have I ever made a game without coding? No, I haven't. I mostly do programming. I want to add rotation as a factor to this as well. I want to test this. I haven't tested rotation yet. Sorry, let me just add this in quickly. I just want to make sure my models fully work with like all of the bits and pieces here. Oops. I don't see why rotation wouldn't work, but we're going to try it. Where am I drawing these? Here we are. These are very ugly lines of debug drawing code. I think this should make it rotate if all worked well. Nice, there we go. Yeah, so the models rotate, which is kind of crazy to see, kind of trippy. Kind of want to add bullet tracers. Should I do that next? Add little bullet tracers when I shoot. That could be fun. Yeah, I need to add animations too. Animations are going to be difficult because you need to like do like skeletal animations probably, and that's a whole other. That's going to be another like 2 weeks of grinding, I think, to get that working, because those are a bit complicated. I actually have a lot of the boilerplate kind of prerequisite stuff in for that though now, which is exciting. So let's add bullet tracers. That could be fun. I'm just gonna keep adding crap to the side here. Let's add a new file, tracers.hpp, tracers.cpp. That's what I'll call them, tracers. What is Siri doing? Why is Siri talking to me? When reloading. All is procedural now. Yeah, all the animations are just like procedural. Yeah, you're right. So it's actually really simple the way my animations work. So like you can see when I stand, the gun kind of wiggles around in kind of a somewhat natural way. Literally all I'm doing to do that is I'm sampling like a noise function. And I'm applying it to like the yaw, pitch, and roll of the gun. And I just like do it slowly over time so it looks like kind of natural. And then when I shoot the gun, the recoil is just kind of like a little springy mechanism where I have a velocity, but then a dampening factor that tries to like reverse the velocity. So basically when I shoot, I just apply like a random intense, I guess, impulse of speed. And then it tries to like spring it back to the original position. It looks a little intense right now because the field of view is really high. And the velocity and the kickback is probably a bit too strong. Yeah. Yeah, I know how they work I've implemented them before. I just never implemented them in like a proper, efficient way in a game engine. I've just kind of done it as an experiment. So I'll need to like actually think about, because yeah, like I'm doing the whole engine from scratch here. So I need to think about like every piece of the pipeline here. It's not just getting them to work in like a shader, right? It's also like, how do I plumb the data through from like the files on my hard drive in the asset folder into an efficient format that I can like load in, and then when do I bind it to the graphics card, you know, like when do I bind it for the draw call? It's the interpolation between bones. It's like all of that stuff is needs to be built on top of all of this. It probably looks weird because I'm just doing like a multiplicative blend, I guess, when it should be additive, I assume. So it looks like things go dark rather than adding, which it should do. I can maybe fix that actually. Let's try to fix that before I do the tracers. So where do I draw the muzzle flash? I need to just know what alpha blend to use for this. Blend mode, color. I never remember these blend modes. Is it like... Let me think about this for a second. The destination color. The source color is source color. Blend factor. Maybe it's just the operation I need to change. Let's try these. Let's try this setting. My intuition for the blend modes isn't very good. Like, whoa, now this looks crazy. It looks a bit better, actually. I get some weird, like... When the texture is not transparent, it does like a weird thing. That does look better, though. Yeah. I'm going to comment this out, though, for now, because I'm not too worried about this. Let me add the tracers. I want to add little gun bullet tracers. That could be fun. Let's see. I'll probably do visible tracers. Let's see, can I get this done in like 45 minutes? Because that's as long as it's as long as I can stream tonight, then I'm probably gonna take a break, turn it off. So 45-minute little bullet tracer stream. Let's do this. So we need a concept of a tracer. This is basically a little particle system I'm gonna write. It'll be pretty inefficient though in the beginning until I make it look better. So we have like, I guess 3 positions. We have a start, or 2 positions, end. Let me think, how do I want to do this? Oh, I need types, or math. Core math. So we want our types. Well, I guess what we have first and foremost is we have a direction vector, or I guess a velocity vector, and then we have a position. We'll just first do it as like a line position, right? And then we'll just do the particle simulation first, like get the bullets to fly away from the camera. So that's like our type for our tracer. I don't know why I'm doing these lines. So we'll have like just a we'll have a max number of visible tracers, which will be, I don't know, like 128 maybe. And we will have an array of these things: static, tracer, tracers. And then we will have a pointer, not really a pointer, an offset into this array. And we'll have a Boolean flag on here, whether this thing is alive or not. This is just some rough code just to get the impression. The font is Iosevka. Iosevka. And I have in my GitHub, or in the description, I have like a link to my settings for VS Code if you want to like look at that. A lot of people ask about that, so I've started putting it in there. We'll return the current position as well, maybe, from this. Or no, we'll just do this. So we copy these. Oops. Copy these. We want an update and a draw function as well, I think. Let me add that too. So the first thing we do on init is just to make sure this thing is nulled out. So we will just loop through all of them. I'm just going to placement new just because it ensures that, you know, the constructor runs. Some C++ fun stuff. We'll set current to 0, just to make sure all of that is nice. How many languages? Well, this is just C++, so I guess the answer is 1. You can probably get away with just 1. Maybe it's good to know more, though. Maybe it's good to know JavaScript. I use JavaScript for my little custom plugin, so that's always fun. Little web dev action. All right, let's worry about, yeah, we'll do create now. So when a tracer gets created, basically we know, so like if the current pointer is equal to the max count, then we can't do anything. Here, we'll put create at the bottom, actually, separate from everything else. I think it's just the regular version. I don't know, to be honest. I don't remember. So if we are at the current, this current is at the count, then we know that we don't have any free particles to allocate from our particle pool. Otherwise, we know that, I guess, the tracer is the one that's at that position, at current. So it would be current, or tracers, current. And then we need to increment current to be, I guess I will return the index here, since that is useful. I also have one that's like destroy. We'll take in the index. So we can write the create and destroy function right next to each other. So this will just return, I guess, usize max. And then, so we need to increment current up to the next available slot. We'll do tracer.alive is true. So for current is less than tracer count max, and tracers current is dot tracers current dot alive. Current plus plus. So that will increment us to the next available slot, and then we just return, I guess, we do this. Return index. So this basically, a little bit of magic code here, should always allocate us a free tracer that's not currently doing something. And then when we destroy a tracer, we're just basically freeing it back up. So we need to check first, just for some sanity. I guess we can assert here. Assert that index is less than the max count. Include core debug. And then we basically set the tracer at index to alive is equal to false. And then current is equal to the minimum between index and current. So that just sets it back down to the lowest spot. It's a bit of both. A bit of both. Most of the models I'm just downloading though right now. All right, so that should allocate us tracers. Now we just need to update them. So let's loop over all of them. And if the tracer, I guess we do tracers current. If the tracer is not alive, then we don't do anything because that doesn't mean anything. And tracer at position is plus equal to the tracer dot velocity. And maybe we can give tracers some gravity too, but we'll do that later. And then drawing them is kind of just the similar thing. For now, I'm just going to draw them as lines, because I have a utility function for that. So it'll be like const float v3 p0 is equal to, I guess, tracer.position minus. Here, let me get a vector float v3. We'll normalize the velocity just to get the vector, a unit vector for this thing. So that's that minus some distance. We'll go like 10 units maybe. And then 0.1 would be plus that times 10 units. I guess this is redundant. We'll go length. Half length would be this. Minus half length plus half length. Then we just draw, include utility. And then draw line 3D. 0.1. Thickness, we'll make it like 4 pixels wide for now. We'll make it yellow. So that would look good. All right, so that should work in theory. Let's just add it to the scene. So when we initialize the scene, we want to like initialize tracers.init. We free the scene, we'll just free the tracers. When the scene draws, we'll just draw these in here after everything else, I guess. Particles. We'll draw them here. And then we need to update them. We'll just update and draw at the same time, even though not the best practice to do that. And then in our weapon fire code, we just have to create some tracers. So when we click fire, now this is interesting. Where do I create particles? Do I do particles in here? Weapon, get ray, reticle world. It doesn't matter. We'll just do stuff here. So I guess we'll create it at that position. Make it fly at that speed. We'll see if this works. Well, I don't see anything, so that's always a a concerning sign. I should see something. So what did I mess up? Interesting. Are we getting anything when we create these? Oops. It could be flying backwards. No, I'm not getting anything. Am I not incrementing current? Index current. Interesting. Why didn't that work? It's like not incrementing current. What do I do in particles? Did I mess up my loop? Because these should be basically the same thing. Oh, I'm not setting the position. That would explain it. I never gave it this. Tracers. Index dot position equals position. So obviously I wouldn't see it because it wasn't being given any information. Alright, well now it's getting information. I still can't see it though. So I guess the next question is, are we updating? Well, we're updating all right. Maybe it's flying so fast because I'm not doing delta time. There we go. That explains that. So it is probably spawning. It's just flying at the speed of light. No, we still don't see anything. Well, actually, I did see something. Yeah, there we go. There's something. They're really fast. Let me slow them down. Too fast. I didn't expect it to be that fast. There's a bug here, I think. This needs to be up here. I no longer see anything. Oh, this should be I. This should be I. Of course I'm not seeing anything. So many typos. That explains why they're flying so fast. I was like, I'm pretty sure that my units shouldn't be going so crazy. Alright, let's get the speed back up. I was like, I'm pretty sure 10 is a pretty reasonable value. If anything, too slow. They look pretty stupid. Yeah, you were right with the current thing. That was a typo. Seems like they're all not flying in the correct direction though. Like when I shoot down. It's hard to tell. Let me turn no clip on. Might have hit my limit. Yeah, I need to change that as well. Like those shouldn't be backwards. Interesting. Let me just shoot it from the camera's position and look vector just for a test. I can delete this now. No, this is a double. I need to do this, really. I don't have implicit conversion between my double and my float matrix, or my vector types. Unfortunately, I'm using Quicksilver. I shouldn't be drawing these as lines either. It's hit scan right now. I'm just adding tracers for fun. But yeah, ideally I shouldn't just be drawing these as flat quads. The bullets should have like some volume to them, because at angles you can see how they get like kind of chopped off. It looks kind of weird. It looks stupid. I mean, I could add that as a feature. I don't have anything really too special with the crosshair yet in this game. Now, ideally I want the bullet tracers to come out of the actual barrel of the gun. It's a bit tricky though, because my gun it's not rendered in world space. Like if I go up to a wall, you know, it's like I'm not clipping through the wall. So the gun's kind of in a separate coordinate space. You talking about the FPS? The FPS goes a lot higher too. It's not so high because I'm streaming right now, so my PC is under a bit of load. But if I wasn't drawing all this debug stuff, it'd be a bit better. Here, let me turn the debug stuff off. I'm like spamming draw calls at the moment. Let's see what FPS I get in this level. There we go, 3,000, 4,000, pretty decent. Kind of bounces around, quite drastically actually. Yeah, I can explain what I'm doing there. Let's turn the debug stuff back on because it's cool. Yeah, so I just added the tracers within the last like 15 minutes. But what I want to do for this game is I want the reticle, so like the crosshair in the center, the reticle. You see how it like kind of moves around with my gun, and like if I get close to a wall, right, you see it like actually kind of goes where the gun's pointing. And if I shoot, you can look at the particles that spawn. So the particles actually come out of, like the bullet ray comes out of the gun barrel. And obviously I can like aim down sight to prevent that from happening. But like it's cool because then the recoil actually like, well, let me turn off the tracers because the tracers look horrible right now. So yeah, the bullets actually do fly where the crosshair is, so you get like realistic recoil with where the bullets go. It's kind of the idea I'm going for. The tracers are just visual though. So the bullet actual like hit scan logic does work correctly with the gun. It's just getting the tracers to visually line up with where the gun is pointing. Because like technically the gun here, when I get close to a wall and I zoom in, technically the gun is like within the wall right now, right? Because, but just the way I'm rendering it, it always renders on top. Because otherwise you'd see the gun like visibly clip in half as you go through the wall. But if I'm shooting a tracer, a bullet tracer, which exists in world space, like world coordinates, the tracer would spawn like inside the wall. Or if I'm looking to the left, it's like getting that coordinate correct is kind of tricky in certain circumstances. So yeah, it's a bit of a interesting thing to solve, I guess. And that's why the hit scan logic is actually separate from the tracer. The tracer is just like a visual thing. And yeah, this is a multiplayer game as well. So like I can demonstrate. So like the left one here is the server. So the server doesn't actually see anything because it won't actually be a playable character. Or the right one's the server, sorry. But if I like connect with the client, you can see my player model is rendering in the wrong position. But you can see like, maybe if I just put 3 guys in here, or 4, let's do 4. Let's do the crazy test. So now we got 4 applications running. We'll make the top left the server. We'll have the server kind of just no clip in the air looking at everybody. And then we'll connect. Here we go. Here's one guy. Here's another guy. Here's a third guy. I need to fix... I haven't done any gameplay with the actual characters yet, though, so it's just like the most basic player movement networking code. It renders in 144 because I cap the frame rate, so I don't let it just rip because otherwise my computer starts tweaking. But you can see on the bottom here I'm getting like 3,000 currently with this screen. If I uncap the frame rate, and I need to delta time my knockback. It looks like I've broken my knockback when the frame rate's too high. Well, it's just like opening a port, a network port. So it's like classic, like socket-based connection. It just happens to be that I've implemented the server into the game code, like into the client. So like I could, if I wanted to, make the server a playable entity as well. But my idea is that the server will be like a dedicated instance that won't actually have a playable UI. I just haven't written the netcode yet for that. Because like the server you would run on just like some server somewhere and then people can connect. And you would have maybe like a server list or something. So yeah, that's how that works. So that's interesting. Yeah. All right, let's see. What can I do with the tracers to make them not look so hideous? Maybe if I give them a model. Let's give them a model with a bit of depth to it. Oops. Let's give them a add mesh. Is there a way to like do a capsule model easily in Blender? All right, let's add a mesh. Let's just add a circle. Or no, we want to add a sphere. Sphere. You can tell my Blender experience is not very good. So we will scale it along. Scale it along, wait, Y and Z. How do I do both at the same time? Oops. I'm horrible at Blender. I don't know what I just did. Okay, I put it into... Here, let's do this again. So we want to scale across Y. We'll just get this to be like... I'm just looking for an elongated kind of sphere thing. And then again on Z. That's not Z. This will be my little bullet beam. In the future, I can get fancy and do this in like a shader. Just have it like procedurally generated volume or something. How to square a circle. All right, and then maybe we'll extend it on X a bit more. Yeah, we'll do that. That'll look good. That'll look crazy. All right, let's export this. We need to UV map this actually. Does it have a UV map? First and foremost. How do I get it to show me what's happening? Am I not in edit mode? Edit mode. Okay, it is UV mapped. That's cool. All right, let's export this as an object. We'll call this new folder bullet or tracer. Tracer. Triangulate. Export. Now we need to give this thing a texture. So tracer. How to square a circle, yeah. Let's just copy this thing. Paste. And we need a texture. We'll just go in paint here and give ourselves a little texture. This is just a proof of concept, by the way. Just a proof of concept. See, it didn't even give me a material. So I need to put one in here. So I'm just going to steal it from here. Use material tracer. This will be called tracer.model. Tracer, tracer. Cool. And then scene. Oops. Let's build this. Make sure this builds. All right. Cool. Runtime. Tracers. So we want to include my model class thing. We will have a static tracer, static model. And we will initialize this thing. And we'll make sure to free it as well. And then drawing this will be interesting. We won't draw it with rotation yet, because I'll need to figure that out. And then does this set up... okay, so I need a scene. I need this. I need a command for this. Yeah, I have both float and double versions. You think using this method you can make it look decent? Yeah, I can make the game look decent, I think. I just need the right shaders for it. Because now I have like a proper material system built into the build pipeline. So now it's just a matter of actually writing shaders to do lighting and stuff. And there's a bit of work I would need to do to set up like a rendering system for like a scene graph and stuff I would probably want, and like doing culling and stuff. That would kind of be up to my game to implement that. And that's something I might do on streams here coming up in the coming weeks. We'll see. I think it could be fun to slowly upgrade the assets to look more... I don't think it's overrated. It depends what you mean by scene graph. Like, at its most basic sense, a scene graph is just a collection of, like, draw calls that you can prune in some way. So, like, you might want a scene graph so you can frustum call and, like, sort your draw calls or something. Okay, this should work, I think. And they should... This does not work. What happened to my things? Did I turn the rendering off? I did. Alright, let's turn that back on. Let's turn off the multi-launcher. I don't need 4 of these instances running at the same time. What kind of craziness is this? Here we go. Now we have little tracer beams that don't rotate. Now the question is, what is the... what would be the direction of this? I don't even know. How do I derive the direction from a vector? Because if I send just the rotation from the normalized velocity, I don't think this is going to work. Because rotation isn't a velocity, right? I need to like do trigonometry to figure this out. Yeah, like that doesn't work. I could tell you words per minute. I think it's actually like 140. All right, let's see. How can I get this? So I do some of this in the camera code. I don't remember the math for this. I calculate the yaw and the pitch from... Or do I do it backwards? Oh, no. I don't remember the derivation. Do I need to take the arc sign? Or it's like the tangent? Let's figure this out. Let's use our big brain to figure out what we need to do. So if we want to get... Yes, I did figure it out. I figured it out, and I can actually easily demonstrate what the problem was, because it's pretty funny. I'm making the buses rotate right now, so let me turn the rotation off for a second. Yeah, so the problem, I figured it out. I figured it out right after the stream ended, actually, which is kind of funny. So it wasn't an off by 1 error. It wasn't anything like that. It was actually a hash map collision with my... So basically for context, when you parse an OBJ file, like the wavefront object model format file, you have this list of faces, which are like these F lines in the file. Let me go to the file. If I like go F, you have all of these faces, right? And they give you these tuples, these 3 index pairs, right? Or I guess not pairs, tuples, right? So basically, what you have to do is you have to manually build your index buffer from these tuples. And these tuples uniquely identify an index. But these can be reused. So you can have like multiple of these be the same thing in the file. So essentially what you have to do is you have to have some sort of lookup table where you like insert these and then you like look up ones if they already exist or not. So obviously you use a hash map for that. And I was using a 32-bit hash key basically for my map. So I was using 32-bit key from those tuples. And it turns out that a 32-bit hash key, assuming like a perfectly even distribution, like you have a nice hashing function, the probability of a collision where 2 keys map to the same value in the hash map approaches like 100%, a lot quicker than you would expect, which is interesting. So it turns out that after about 50,000 like unique entries in the hash map that uses a 32-bit key, you're at about 50% chance that any 2 of those will collide and map to the same value. So this is actually the birthday paradox, if anyone's heard of that. So the solution was I should have been using a 64-bit key. And as soon as I did that, the problem went away. Because a 64-bit key is like astronomically less likely to collide. It takes like billions of entries before you have like more than a 10% chance of a collision. But this is a good lesson for why hash maps are actually ugly solutions to problems. I kind of hate using hash maps because it's like, there is a statistical chance that, you know, one piece of thing, like one thing might alias something else just because of your hashing function. Which is fine if you're inserting data into a hash map, because you can write your hash map to like explicitly never overwrite. There's like implementations of hash maps that don't overwrite data. But the problem is if you're retrieving from a hash map with a key, there's no way to know specifically which version, like which item you want. So it's just going to give you the first one. And that was the problem. So it was just giving me the wrong index when I was building my index buffer. So yeah, that's a that was a fun bug. But yeah, on the bright side, my object loading code was otherwise perfectly fine. So that's good. And I've went and refactored the rest of my build cache system to use 64-bit keys for everything, just because I never want to deal with this again. All right, so let's use our big brains for these rotations. So I guess the pitch is what? The pitch is along the y-axis. So let's get pitch first, because I can reason about pitch. So like float pitch is equal to, would this be the arc tangent atan of, I'll do atan 2. This is, what is it, opposite over adjacent? Is that a tangent, opposite over adjacent? So you would do, I guess, here, let's get the velocity. Vector is this. And comment this out. So we have, I guess, if we're over the y-axis for pitch, that would be tracer velocity z over tracer velocity dot x, right? X. What does this give me? Does this look nice? This is like some high school trig. All right, I think the pitch looks right, actually. I mean, oh, maybe not. Here, let's make these things not actually move, despite. What do you mean transfer script? There's no script to transfer. Okay, this didn't do anything. Is it applying rotation? Pitch. Degrees to, oh, it's thinking it's in degrees. Oh, that's annoying. Why am I doing that? Let's just do it anyway. Why would I do my math in degrees? All right, so we're correct. We're just inverted. Because if we like look down, it points up. So we need to, I guess, invert z. Like my game code would only work with my engine pretty much. We'll put the spinning bus back. I need to get that spinning, the spinning rat. That would be a good thumbnail content, actually. Let me find the rat model. This is a little tangent. Everyone seen that spinning rat meme? Rat model. This is a low polygon rat. I need the low poly rat. Free. How do I set this to free? If anyone has the link to the low polygon rat model. Here we go, Sketchfab. This is what I'm looking for. Can I download this? Will it let me? Yeah. No, I don't want to log in. Alright, maybe it's not worth the effort. Alright, so now the pitch looks right. Now we just have to do the same for the yaw, which would be on the Z axis. I'm sure there's a more efficient way to derive these than using the inverse, the arctangent. So the Y is on around the Z axis. So I guess you would take Y over X. We'll try that. Y over X. We'll just see what this does. Again, I have flipped it. Classic. Oh, that doesn't look good. What happened? Interesting. High school math. I love it. You can tell I don't do this. Maybe I just need to flip the order of operations on these. Like maybe it should be yaw and then I pitch. We'll try that first. There we go. There we go. Just a little order of operations. Wait, that one didn't look right. So it doesn't like it when I look too high up. Like that. Well, nah, yeah, it's messed up. What's the difference between, does anyone know the difference between like the A tangent function that takes like this? Like the single version and then the double version. I think there's something you can like get the quadrant information from the one of them that you can't get from the other. Like that looks better, doesn't it? We're just gonna roll with that. I think that looks better. Better. Yeah, maybe that was throwing it off. This looks better now. No, it's still fucked. It's not quite right. It could be that I'm using the velocity, which is like, and when I normalize it, I'm kind of destroying. Let me not normalize this. I might not have to normalize if I'm using like the ratio like this. I'm sure there's a better way to derive these values from each other than using the arctangent too. Yeah, no, that's messed up. Oh well. I'll figure this out later. I don't actually want to render them as models. It's kind of dumb. Yeah, they're hit scan. I'm just rendering the nice. I'm just rendering tracers right now. I just implemented this. Started implementing it like 30 minutes ago or whatever. Yeah, I do want to do projectile. Yeah, I explained this a bit earlier, but I have like the crosshair that moves with the gun. Right, so if we look at the particles, those are like what the hit scan's doing. The particle does come out of the gun barrel basically and like shoot where the gun's aiming. So when I get close to a wall, the gun does this little like pull in animation. So if I hit fire, it like shoots over there because that's where it's pointing. So I want, eventually I do want the tracers to like also come out of the gun. And then I don't want the particles to appear immediately, right? It'd be cool to simulate them. Was I never using that? Oh, I wasn't. You're right. Interesting. Yeah, I should have been using this. I don't think that's going to solve my problem, but that was a good call out. I mean, it's still broken. I think my math is just wrong. I could do this. I could draw it using I could pass it like an explicit. I could write an override of this function basically where I take in a rotation matrix potentially. So like rotation. And then I multiply the rotation matrix in here, I believe. And then I can get this from the camera. So I could do it like, what is happening? Oh, I need skin still. So with the rotation matrix, it's so much easier to reason about than trying to do like trigonometry. I try to do a bit of work every day just to keep myself on a forward trajectory. Most days I kind of don't do too much though. All right, let's try this version of the function for the tracer. So instead of using a rotation, we'll use the cameras dot. I don't have access to camera here, do I? Because I don't include it. Actually, I gotta include scene. This might work. I don't actually know. This might not work at all. Well, I guess now it's using... now it's applying the matrix as I move my camera, which is kind of dumb. So I would need to then also store this on the tracer, which is not a very intelligent way of doing this. But I could do this. I could put like the rotation matrix and then... See, this gets dumb. So like I don't want to do this. I should be able to derive it from the... I should be able to derive this from the velocity. But it has a dirty little debug thing that I can just do tracer.rotation. Let's delete all of this stuff except for scale. Let's see, is that all I need? I can delete the camera from here. See, now they're like the correct orientation. And like I can elongate it along X maybe, so it's thinner. It looks really dumb though. It's hard to see against the sky. Yeah, it looks really dumb. It's because the speed isn't right. Let's make this thing a lot faster. No, it's like too fast. I should turn on anti-aliasing as well. Or like multi-sample or something. Let's make these things multi-sampled so it doesn't disappear into nothingness into the background. So there's some nice aliasing that happens. And like maybe I would want to scale up the bullet based on the distance. So like I can do something like so I do need the camera back. Just so the bullets stay kind of like a constant size, we would want something like... It's no limit right now. We are going blind in this one. Yeah, my bad. A flashbang alert when I fire the gun. So we do like the distance between float v3 distance. We pass in tracer dot position and camera. And there's probably some way I could get like a constant pixel size based on distance. Oops. I know there's like a way to derive it with the field of view. Actually, how would this work? Minimum. Let's do like a linear fall off, which won't look very good for now. Really, so like every, in this, here, we'll put this on one line. So like every 200 units, it should gain a like an extra bit of girth. If that makes sense. Yeah, not quite. See, now kind of like it's still visible off in the distance, which is kind of cool. Kind of an effect. But this thickness is like a value I would want to derive also from the perspective. I love the spinning bus. Oh no. See, I can get myself stuck here. I have a soft lock in my map. You can get stuck in the hole. Can't get out. I should add like ledge grab. So you can shoot, you jump up and grab the ledge. That'd be cool. Yeah, now I'm split. Do I want to work on rendering stuff? Like, do I want to make the game look prettier? next stream, or do I want to work on gameplay? Because it's always fun making stuff look pretty, but if it's not a game, then what's the point? Oh, my cat brought me a toy. Okay, goodbye, kitty. If I turn the skybox off, it would be a bit easier to see as well. Let me turn the sky off. So you can see the bullet tracers out there. It'd be cool if they had some gravity as well. They kind of decay over time. Or a woozing effect. Oh, yeah, that'd be fun. A whooshing. Phew. Get like some Doppler effect in there as well. I'm using... So the engine's cross-platform, so the API I use kind of depends on what platform it's running on. But I'm using OpenGL, DirectX 11, and Metal currently is my 3 implemented backends. So yeah, people who see the no libraries thing ask about that frequently. That's why I had to put an asterisk on it. Because I'm not doing like a software renderer. Obviously I have to use basically one of the graphics APIs to actually like do graphics. So yeah, but I have my own graphics abstraction layer that bridges across all of them. And I have my own shader language that compiles for each of them. So I have a single shader language that I write my shader code in and it gets translated depending on the back end. So the engine is technically graphics API agnostic in that I've implemented my own rendering abstraction system, basically. Add the 360 spinning rat. I want to add that now. I have to find it. Sketchfab, is it this one? Or Turbo Squid? I want to find a free one. Let's get the rat in. This will be my final goal of the night, is to get the spinning rat, and then I can add this as the thumbnail. So let's create an account. Oh, I just doxed myself. Alright, doesn't matter. Alright. Does it come in... Okay, goodbye, kitty. FBX. I guess I'll have to convert it to a OBJ file. Oh my god, my cat is so annoying. Go! Say hello to the cat, everyone. Or say, yeah. Cat can say hello to everybody. Master clickbait technique. Oh my gosh, my cat is so annoying. Okay, 1 second. I have to put the cat away for a second. Come on, kitty. Let's go. Alright, I'm back. The cat gets a quick timeout. Make sure you can shoot the rat. Alright, let's see what this model file has. Does it have textures? It does. Sick. Alright, let's get these. Let's just put these in my downloads folder for now. And then in Blender, let's import the rat. Oh, wait, we want to import an FBX file. Import FBX, downloads, source, rat. All right, looking good already. Let's make this thing a little bit chunkier. Hopefully this thing is UV mapped already. I think it is. All right, I'm just gonna assume it is. I'm gonna export as OBJ. And we'll have another folder rat. And then we'll get the rat in there. Call this thing rat. Export. Do you like my commentary for my moves here? So we need to copy the model, paste the model. This is how I define all my asset types. I have these little JSON files, and that this like describes what my asset contains. All right, so map kd would be rat.png. Just make sure it's using this. Use MTL. Yeah, we'll just be fine with that. And then we just need to get the texture from the download folder. Assuming it's the base map. Rat. This is a crazy looking rat. All right, and then in the scene, we'll just add another one of these little things. Model rat. Model rat. Here, let me build my asset types. All right. And then we want to rotate model bus dot draw. Let's draw the rat somewhere. We'll get rid of the cubes for now. We'll just draw the rat where the cubes are. All right. We should get rid of the cubes debug lines. Hopefully this works. I'm seeing a rat. I love it. This should make good clickbait, good thumbnail content, is the spinning rat. Let's get the sky back in here too, before I forget. Draw sky. Where is it? Draw sky. Let's get the rat's little debug outline, just so we can demonstrate. Demonstrate that this is all working correctly. It's huge, yeah. Let's put it at a rotation that's slightly offset, like 90 degrees. Just so it looks nice on the thumbnail. I'll have both the rat and the bus. I should go the other direction. -90. The game is now 99% done. Yeah, here we go. This looks like some good thumbnail content. This will draw in all the viewers. I'll go viral after this. C++ game engine dev, bracket, no libraries, bracket, no AI, bracket, with rat. Oh yeah, I should do the 357. Yeah, that'd be great. Let's do that. Let's do that. I'll do that before I end the stream here. Okay, so we'll do sine of time, or sine of angle, divided by what? 357, right? Is it division or multiplication? I don't remember. We'll just see what this looks like. Or division or like offset. I forget which way this goes. Oh, whoa, what is happening? It kind of looks like the rat is like eating something. The issue is I'm not doing... So annoyingly, I had my matrix math using degrees. Or like I have a degrees conversion happening. All right, here we go, here we go. And we'll just multiply this times like 0.1, because it's a little too fast, a little too fast. We need to put it up in the sky a bit higher. Oh no, I put the bus higher. The outline doesn't have the transformation. That's why it's rendering in a weird way. Let's fix the outline as well. Let's just do the rat. Should make for some great content. Here we go. Now we get some nice... Actually, it doesn't look right. What happened? Somehow the points aren't correct between the debug and the other thing. I don't know. I'll figure it out later. Doesn't matter. It's like the debug line's like ahead slightly, or it's not accounting for one of the twists, because you can see the tail kind of clips out every now and then. You gotta look like put a serious face on. Let's get a gun that doesn't obscure them. Make cheese. The shit you see in your dreams. I'm just glad to see this stuff actually works, because getting model loading in and asset in materials is going to be a game changer for making this game look better. So I'm excited. But yeah, I'm gonna end the stream here. Not a marathon stream like yesterday's was. Maybe I'll stream again sometime this week. I'm not sure yet. I think for sure on Sunday though, so you can look forward to that. But yeah. Thank you guys for watching. It's been fun. You can enjoy the rat here. See you guys.